Think about the basic rules that make a planet feel like home. We expect a 24-hour cycle of day and night. We expect a year to last 365 days. And we rely on a protective atmosphere to shield us from the extremes of space. At first glance, Mercury looks like an exact clone of our own dead and silent moon, a tiny, gray, heavily cratered rock drifting through the inner solar system. But that dull surface covers a world of conflicting characteristics. Despite orbiting right on the edge of the sun, Mercury harbors deposits of freezing water ice. It is the smallest planet in our solar system, smaller even than moons like Titan or Ganymede, yet it packs so much mass into that tiny frame that its density is second only to Earth's. The mechanics of its orbit and spin are so mismatched that a single day on the surface actually lasts longer than an entire year. Faster, more urgent, Telm. This tiny world occupies the most hostile real estate in our solar system, functioning as an extreme edge case that tests the limits of planetary science. This animated schematic maps the inner solar system. Notice Earth's relatively circular, steady path. Now look at Mercury. It follows a tight egg-shaped orbit, hurtling through space at 47 kilometers per second. At that speed, it completes a full lap around the sun in just 88 Earth days. That rapid movement is why the Romans named the planet after their winged messenger god, Mercury, who was known for his speed. But while the planet races through space, it spins slowly on its own axis. A single rotation takes 59 Earth days to complete. Astronomers call this a 3-to-2 spin-orbit resonance. Because of its elliptical path and the sun's gravitational pull, Mercury's rotation and orbit are locked in a strict mathematical ratio. For every 2 full orbits it makes around the sun, the planet rotates exactly 3 times. That ratio creates a distorted schedule for daylight. A solar day, the time it takes for the sun to rise, set, and rise again in the same spot, takes 176 Earth days to finish. If you lived there, the calendar would look entirely alien. You would finish a whole year and celebrate a birthday every 88 Earth days, meaning your year is half as long as your day. You would only see a sunrise once every 2 Mercury years. Standing on that surface, the sun dominates the sky. Because it sits an average of just 58 million kilometers from the star, sunlight reaches Mercury in only 3.2 minutes. The sun would appear 3 times larger and 7 times brighter than it does from Earth. You might expect this proximity to make it the hottest place in the solar system, but Venus actually holds that record. Mercury lacks a thick atmosphere to trap and hold on to solar heat. Without a blanket of air to regulate the climate, the planet experiences extreme temperature swings. During the long solar day, the surface bakes at 430 degrees Celsius. But once night falls, all that heat escapes into space, and the temperature drops to minus 180 degrees. Mercury has almost zero axial tilt, meaning sunlight hits the equator directly. Deep craters at the north and south poles remain in pitch-black shadow year-round. This topographical scan reveals what hides in that darkness. Even though the planet sits practically inside a star's personal space, these shadowed craters act like cosmic freezers. They maintain temperatures low enough to preserve deposits of water ice. Forming on the absolute edge of a star strips a planet of any normal climate system, creating an environment of simultaneous fire and ice. That same proximity to the sun explains why Mercury travels alone. Its gravity is too weak to hold on to any moons or ring systems. The sun's gravitational pull would simply rip them away. This cross-section lets us compare its internal structure to a standard rocky planet. Mercury is barely larger than Earth's moon, yet it is the second densest planet in our system. That density comes from the inside out. Mercury possesses an iron-rich core that makes up 85% of the planet's entire radius. It is essentially a metal cannonball covered by a thin veneer of rock. As this massive iron core has cooled over the last 4 billion years, it has physically contracted. This process is actively shrinking the planet's total size, reducing its radius by up to 7 kilometers. You can see the scars of this contraction on the surface, where the rocky crust has buckled into massive cliff-like fault scarps. These features sit alongside ancient impact sites, like the 1,550-kilometer-wide Caloris Basin. The solar system's smallest planet is crushing inward, wrinkling and folding under the weight of its own cooling iron heart. We usually think of Venus or Mars as Earth's closest neighbors, but because Venus and Mars spend huge chunks of time on the far side of the Sun, Mercury actually spends the most time as Earth's closest neighboring planet. This spatial trajectory map shows why our closest neighbor is incredibly difficult to visit. Any spacecraft heading toward Mercury is falling into the Sun's gravity well. As the craft approaches, the Sun accelerates it so fast that engineers have to expend huge amounts of fuel to slow down and enter orbit. Because of those extreme energy requirements, missions have been rare. Our earliest up-close glimpses came from the brief flybys of the Mariner 10 spacecraft in the 1970s. It took decades of careful planning before the Messenger probe finally managed to stick the landing, becoming the first spacecraft to orbit and map the surface comprehensively starting in 2011. A joint Japanese and European mission called BepiColombo is currently navigating that complex path. Slated to arrive in 2025, it is equipped to map the planet's magnetic field and measure the exact composition of its oversized iron core. Mercury is a world of hostile extremes. But understanding its unique mechanics helps us appreciate the rare, stable, and protective environment we take for granted right here on Earth.